Welcome back. We are talking lesson 3 and trig is the topic. We are trying to look at trig ratios of other angles. We are trying to look at trig ratios of other angles. We have discovered that we have 4 quadrants. We have the first, the second, the third, and the fourth quadrant. In the first quadrant, angles range between 0 and 90. Those are acute. In the second, they range between 90 and 180. In the third, we have from 180 to 270, and in the fourth, we have from 270 to 360. Those are exclusive angles. Now, we've discovered also that the sine, tan, and cosine behave differently in all those 4 quadrants. Apart from the first one, where the sine of all angles in the first quadrant, the trig ratios of all angles in the first quadrant is going to generate for you positives. When you go to the second, it is only the sine. When you go to the third, it is only the cosine. When you go to the the third, it is only the tan. The rest are negatives. In the fourth, it is only the cosine, which is a positive. Now, I want to use this as my example. Roman 1. I have, if I draw my quadrant, it is the sine of 135 degrees. Sine of 135, I can take it to be there. Now, if this is 135 degrees, I can call this alpha. So, if I get alpha and add on 135, whatever that I get is 180. So, alpha is equal to 180 minus 135, which is 45 degrees as the value of alpha. So, therefore, the sine of 135 degrees is the same as the sine of 45 degrees. Why? The reason is, as I'm going to mention. 1. The sine of angles in the first quadrant, sine of all angles in the first quadrant is positive, and so in the second quadrant, so if it is a sine, even the sine of 135 is also what? Positive. If I go to the second one, for instance, can I fix the second one here? Yes, I can. I have the cosine of 240. First locate where 240 is. 240 is here. So we are moving like this. We start from 0. We move up to here. Okay? Now, from here to here, this is 180 already. Then there is an extra. I can call this beta. So 180 from here to here. That is 180. Plus beta gives me the total of 240. So therefore, if I want the value of beta, because I want to look at a representative of the ones that I know, so this one is 240 degrees minus 180, which is 60 degrees, and this is beta. It is the cosine of 240 degrees. We are in the 240 is in the third quadrant. But in the third quadrant, 240 being in the third quadrant, in the third quadrant, cos is negative. So it is the same as negative cos of 60 degrees. The value you get when you press cos 240 degrees on your calculator is the same value you get when you press negative of cos of 60 degrees. Am I making some sense? If you try out with the tan, this one is going to be, for instance, this is the same as, based on this explanation, this is the same as the tan of 30 degrees. Because 210 is in the third quadrant. Tan is positive in the third. 210 is 210 minus 180, which gives you the 30. Cos of 330. Cos, first of all, 330 is in the fourth quadrant. Cos is positive in the fourth quadrant. 330, if I draw something here, 330 is here. So I'm going to move till when I reach there. Are you seeing? So there is a certain angle remaining to make something tangible here. If I call that angle theta, if I get 330 and add on the remaining angle, which I've called theta, whatever that I get is 360. So theta is 360 minus 330, which gives 30 degrees. We are talking in cos. So cos of 330 degrees is the same as cos of 30. Both positive. Why? Cos is positive in the fourth quadrant and our theta lies in the fourth quadrant also. Are we together there? So, ladies and gentlemen, what I've been trying to emphasize here is, can we get trig ratios of other angles using the other ratios we've looked at 30, 45 and 60? Can we use them to get these ones here? Yes, we've discovered that we can. So from there, let's talk about trig or trigonometric equations in the four quadrants. Trig equations in the four quadrants. In the four quadrants. Don't forget that this is the first what? This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. We are starting from 0 to 90 to 180 to 270. Then a complete revolution only happens if you hit the 360 degrees. That's a complete revolution. Now, we can, if you are going to take another revolution, we don't start from a 0. We start from the 360. So from the 360, we are going to go to 450, keep adding 90 degrees. That is the trick. From the 450, you get to 540. From the 540, you go to 630. Then from the 630, this is the second revolution, or the second term. Because you have started from here 0, 90, 180, 270, then 360. From 360, we have moved 450, 540, 630, 720. Okay? Then, if you have to move again, you start from here. If you have to go for the third revolution, so we start from 720 to 810 degrees. Then from 810 degrees, you move to 900. Like this is 900 degrees. Then from 900 degrees, we can talk of 990 degrees. Then from 990, you can go to 1080 degrees. That is the third revolution. It stops there. So, I'm talking of the trig equations. When generating these equations, we always base on our reference. Our reference will start from 0. So the horizontal line is our reference line, or our reference axis. So in the first quadrant, if you generate the angle in the first quadrant, or if you get the angle in the first quadrant as a theta, in the second quadrant, if you want the angle there, it will be 180 minus the angle we've got here. Here it is going to be 180 plus the angle. Here it is going to be 360 minus the angle. These are in degrees. Don't forget to put that one there. So, if you have rotated it twice, that means from here it will be 360 plus theta. These are degrees. This is going to be 540 minus theta. This is going to be 540 plus theta. And this will be 720 minus, this is theta. And so on. But we are using the horizontal line or the horizontal axis. Don't dare forget, angles here follow this. You can cram it if you so want, or you can use, all science teachers take care, ASTC. You can always take it along that line. So, it is from there that I can bring in some examples. Find the values of theta for, find the values of theta for 0 degrees less or equal to theta less or equal to 360 degrees less or equal to 360 degrees less or equal to 360 degrees, that satisfy the following. Roman 1, we have sine theta is equal to a half. Roman 2, we have tan theta, okay, we have and half sine theta is equal to negative a half. Roman 3, we can have cos of theta plus 60 degrees is equal to a half. Then we can have tan theta is equal to negative 0.7660. We can have tan theta is equal to, we have tan theta is equal to 2 sine theta. Then we can have tan squared theta is equal to a third, and have, or we can have cos 2 theta is equal to 0.6428. This is 8. Then we can have tan squared theta is equal to a third. I'm going to calculate all of them. You can add on actually. Roman 8, we have tan squared theta plus tan theta is equal to 0. This is Roman 9. Can have sine 2 theta. sine 2 theta. Sine 2 theta is -1. Then we can have Roman 10 is 2 cos squared theta plus 3 cos theta plus 1 is equal to 0. So we are going to use those ones. We are going to use those ones there. We are going to use those ones there. The first one, I've said I'm going to calculate all of them to ensure that people learn how to generate angles, because as we move on, it will be a huge task if you don't grasp this information in the very beginning. We have sine of theta is equal to a half. What they need is theta. How to get it? What they need is theta. This one should always be at or near you. You say this is the first, second, third, and fourth. We say sine is positive in the first and second. Now look at what we have. We have a half. That is our ratio. So I expect angles in the first and second because our half is positive and the sine is positive in the first and second quadrant. So how do you get the theta? You just say theta is equal to the sine arc of a half. Theta is equal to the sine arc of a half. So therefore, you go to your calculator. You go to your what? Go to your calculator and you press what you need. You have shift sine or arc sine of a half, or you can put it as 0.5. It is the same, and you are not penalized at all. The angle is 30 degrees. Now, if it is 30 degrees, how are you going to get the second angle? That's where our challenge starts from. Remember, you're supposed to satisfy this range. It is from 0 to 360. But basing or focusing on all the rules as we've mentioned them. So, we have 30 degrees. Which other angle do we have? Getting the other angle is as easy as you can imagine it, because we have talked of the 3D equations. So in the second quadrant, if the first one is theta as our reference, to get the second one, get 180 and take off the 30, or the first angle you have got. So the answer is going to be 30 degrees and 150 degrees. Then going to Roman 2, we have sine theta is equal to -1/2. Theta is the sine arc of -1/2. If you feed this in the calculator the way it is, my dear, you are going to discover that your calculator will give you a -30. The calculator will give you what? -30, but -30 does not lie in our range that they have given us. So what do we do? This is what you're supposed to do. You treat this, when you're feeding it in your calculator, treat it as a positive. To get the reference angle you're going to use, I've said, in the calculator, feed this. In writing, it is supposed to be like this. In the calculator, feed it in as a positive. Treat this as what? A positive. If you treat it as a positive, you get 30. Now, remember, this is a negative ratio. Sine is negative in the third and the fourth. So use the 3D equations. We have 180 plus theta and 360 minus theta. So this one is going to be 180 minus the reference angle when you treat it as a positive. This one is 150 degrees. and 360 degrees minus 30, which gives you 330 degrees. Ladies and gentlemen, we are going to pick it up from there. I'm going to finish up all those examples in my next lesson.